So we're going to introduce, thanks Harry, you're also more destructive than Abby, so two from you, that's the baseline. We're going to look at some of our rules for antiderivating, or anti-deriving, sorry. Another name for anti-deriving is integration. Hopefully by the external exams these will be integrated into your brain. We ran through a few of these yesterday. This sign is sort of like, if you think about, well, when we're deriving, right, how do we show that we're deriving? We put the F dash to show that we're deriving. That's how we show that we're anti-deriving. Cool? Similar to dy dx, it's just a way of symbolising that we are deriving. The dx is just telling us what variable we're deriving with respect to. Integrating with respect to. So you know, if we've got a function, you haven't come across functions with multiple variables yet, but if you did have one with k and x, for example, if it was dk, then you'd be deriving or integrating with respect to k. Almost always it's going to be dx though, because x is almost always the variable we're using. Sweet? But it doesn't. In the textbook we see a's, we see b's, we see m's, we see y's, we see q's, we see all sorts of things. So just be aware of that. The second most common thing to derive with respect to is, or integrate with respect to is, t. Why t? What's t represent? Time. So deriving and integrating with respect to time. Here are some rules. These are all on your formula sheet, although they don't all look like this. It's important you know these are good guides. But for example, the sine and cos ones and the e to the power of are all just x. So instead of having hx, they have x. What's the problem with that? What's the derivative of x? So it's going to look like that. So you need to remember that I would encourage remembering these three at a bare minimum, off by heart. Sweet? This one you'll get straight from the formula sheet. You'll use it so much you remember it off by heart anyway. So, with our integration, if we've got x to the power of n just represents any number. So give me a number, Ryan.
5.
5. So x to the power of 5, if I integrated that, it would become x to the power of 6 divided by 6. How could I check if that's right? I could derive this and check that it gives me that. Does that make sense? Anytime we're doing a reverse operation, we're more familiar with one, you can always check by undoing what you've just done. Sweet, we're much happier deriving than we are integrating right now. So I can always check by deriving my answer, and I should get my question back. Sine of hx. Give me a value for hx, Abby.
20.
It has to have an x in it though.
20x.
20x. Sine of 20x equals negative cos of 20x divided by 20. Cool. How could I check that? Derive that. Negative cos 20x divided by 20. If I derive that, I'll get positive sine. 20 out the front. 20 divided by 20 is 1. I'm left with sine 20x. Ta-da. Cos of hx, give me a hx. Give me an x, like an x squared or something, Sam.
X squared plus 6.
Okay, x squared plus 6. That's going to become, see if you can do it before I do it. Cos of x squared plus 6, what do you think it's going to become? I'll give you 10 seconds. What do you reckon? The initial hx was x squared plus 6. Sine of? What's going in here? Does that change?
No.
So it's going to be x squared plus 6, correct? Divided by?
2x.
Exactly. Cool. F of e to the hx. Annalise, give me a hx. 7x cubed. What if I make you solve that? You good? No, who should solve it? Who should solve it? Harriet, good idea. Harriet, e to the 7x cubed.
Yeah, it is 7x cubed over 21x squared.
Very good. And the last one, we only learned this rule recently. Obviously, if we derive ln x, we get 1 on x. I gave you a simple one. This one because I want to get overly complicated. Now, if you think about that, what is that as a power? X to the power of? If we add 1 to the power of that and then divide it by the power, what are we doing? X to the power of 0 divided by 0. Is that possible? So alarm bells should be ringing. So you could probably fall back on that, and then if it comes up being unreasonable, then you know that's your secret rule. But that's also in your formula sheet. Cool? We are going to practice these. Remember when deriving was a big deal? Back in year 11, when we first did deriving and you were all like, the rules are gross and disgusting, and now I give you any function and you can derive it like that, and it's not hard at all. This is much the same. So it'll become very natural. Yes, Abby?
What's with the dx?
The dx is just telling us that we are anti-deriving or integrating with respect to the variable x.
Does anti-deriving just mean going up instead of down?
Yeah, basically. Yeah, we're going to talk about kinematics and which way you're going, but if deriving is taking a power down, then anti-deriving is adding 1 to the power. Cool, they're opposite operations. For we'll talk about question 2 in a sec. There's question 2 on the board. I'm going to set today's work and then we can keep going. It is on Google Classroom, but they're our baseline rules.